Alright, here we are. We're going to be doing part 2, and this is from section 11.6, and it's still on page 762 in your book, and we're going to be applying the knowledge that we went through on the part 1 and doing some examples. Now these examples are very similar or exactly the same as those in the guided practice section in your book, and the guided practice is on page 762. It starts with 1 and it goes to number 5. So these are either similar or the same as those guided practices in the book. So first we're going to just start with identifying the center, the radius, the apothem, and the central angle of the regular polygon. So the center is going to be the letter F, capital letter F. The radius is a segment, and it's FC. Make sure you put your segment above FC. The apothem is a segment, and that is one we just learned. It comes from the center, perpendicular to a side, and the only one in your diagram, right here, is the segment FG. That's your apothem. And a central angle in the regular polygon, we'll name just one. One of them would be angle E to F to D. Alright, to find the measure of angle EFD, you would take 360 degrees, divide it by 5 because there's 5 equal triangles, looking at these 5 equal triangles in that regular pentagon. So if you divide that by 5, you get 72, so it's 72 degrees. Then the angle EFG, E to F to G, just one part of that larger triangle. These two triangles are congruent, and they're congruent again by HL. And if they're congruent, their corresponding angles are congruent. That means both are going to be congruent, and we would take our 72 degrees and we divide it by 2, and so I get 36 degrees. So that's the angle interior. It's actually the central angle, and it's angle EFG. Alright, then we go down to some more application problems. Find the perimeter and the area of the regular polygons. Make sure you do these steps. These are the 4 steps that you need to follow. Formula, substitute, calculate, and label. Be sure you show your work. Alright, for the first one, if we want to find the perimeter, it's the number of sides times the length of each side. The number of sides in this regular pentagon is 5. The length of each side, we have to figure this out. So we go ahead and we are looking for the one side of the right triangle. And doing the Pythagorean theorem, you have, let's call that x squared plus 6.5 squared equals 8 squared. So we go ahead and we take our x squared plus, this is going to be 42.65, and 8 squared is 64. Alright, you'd subtract, and x squared would end up equaling 21.75. You'd square root, and x would equal approximately 4.7. So we need that doubled, because that's the length of the full thing. So if this is 4.7, when you double that, you're in a approximately 9.4. So 9.4 is what we're going to multiply by our 5. So then you multiply those two together, and the perimeter would be approximately 47. And I didn't put units on here, so you don't need to give units, but if you do, just put UN. Then the area. The area is equal to 1/2 the perimeter times the apothem. The perimeter we just found to be 47. Looking at our picture, the apothem comes from the center, perpendicular to your side, so the 6.5 is your apothem. Okay, when you multiply those together, you're going to get the area, and it is approximately 151.6, and again, units, but this time it would be squared because it's area. Alright, that's for your first example. Second example, you have the perimeter, which would be the number of sides times the length of each side. Number of sides in this one is 10. This is a decagon. So 10, and then they're giving you the length of each side is 7. So your perimeter would be 70, and in this case it's inches, and it's not squared because it's just perimeter. The area would be 1/2 perimeter times apothem. The perimeter we have is 70. but we have some work to do to find our apothem. We draw this triangle. There are 10 congruent triangles in the regular decagon, and you drop the apothem. This is a perpendicular. Now I'm going to take that triangle and I'm going to blow that up. So the apothem is what we're looking for. The full side of this triangle is 7 inches, so when I cut it, these two are congruent, and the side will be 3.5 in this smaller triangle. Okay, what you're trying to do is find the apothem, and I need one more piece of information, and I can find it by doing trig. I need this upper angle. I'm going to take 360 divided by 10 would give me each interior angle in the original picture is 36. Since these two triangles are congruent, each side would have an 18-degree angle. So now in my triangle I have the angle, I have the opposite side, and I'm looking for the adjacent side. So when I deal with those, I'm dealing with tangent, because the tangent is going to compare the opposite to the adjacent. So I do my work here. Tangent from my angle, which is 18 degrees, compares your opposite to your adjacent. And now you're going to do some algebra on this. You're going to multiply both sides by a, and you have a times the tangent of 18 equals 3.5. You're going to divide by the tangent of 18, and a will equal 3.5 divided by tangent of 18. Now this is approximately 10.8. So that's what I'm going to put in for my apothem, is my 10.8. Now when I go ahead and multiply this, this turns into an approximation, since I'm rounding things. It's approximately 37.0, and that's inches squared because it's area. Okay, so that's the second polygon. Third one, you have an equilateral triangle inscribed in a circle. The perimeter, number of sides times the length of each side. I do know the number of sides, but I don't know the length of this full side. This is an equilateral triangle. When I draw this radius, it has split it from a 60-degree angle into a 30-degree angle. And I use the 30, 60, 90 triangle method now. I have the short leg, and I want to find the long leg, which is going to take the short leg and multiply it by the square root of 3. So this is my long leg. I need to double it for the length of the side. So it's going to be 10 times the square root of 3. That's what I have for the value of s, 10 times the square root of 3. So when I multiply those together, I've got 30 times the square root of 3, and that's going to be centimeters. That's the answer for my perimeter. Now you leave it in radical form and make sure that your radicals are simplified. This then is considered exact form. If you press the button on the radical, then that's an approximation. Alright, but we're going to give exact answers unless we're told otherwise. The area equals 1/2 perimeter times apothem. The perimeter is 30 times the square root of 3. The apothem was given to us up above, which was 5. So now I have half of 30 is 15, and 15 times 5 is 75. So 75 times the square root of 3 is my answer, and it's going to be centimeters squared. Area equals, this is an equal sign, not an approximation, because I left the radical in the problem, and it's simplified. Okay, those are your examples, and you can go back and watch this again. You can review the notes that you've just taken, or read the section in your book, 11.6, page 762. And then when you do your homework, be sure to show all work and complete your homework. So, good luck.